Good day friends, welcome back to the channel. It's Given again from Techno Drive. I hope you are doing okay. I hope you are alright wherever you are. Thank you for watching the videos. In today's video I've got a Fivestar 8 kVA 6 kilowatt inverter. So this inverter, it's one of the problems that we've repaired before. The problem that we are having here is the short on the battery terminals. So when we connect the battery, the lithium battery, it just trips immediately. So the alarm that's tripping on, it's OCP on the lithium battery. So OCP stands for overcurrent protection. So once you see that on your lithium battery, it means that there's a short on the battery terminals. So you have to check that. So I'm going to measure so that we can see what I mean about the short. Then we can know how to test this thing, because sometimes you can have a fault, you will never know where is the problem. You will think that it's a lithium battery that has got a problem, whereas it's an inverter. And sometimes it could be the lithium battery. That's why we need to check before we can do some repairs. But I've already done some measurements. There's a dead short on the battery terminals, but I'm going to test again with you so that you can see. So this inverter is not the first time that we repair it. There's another inverter that we did the repair. Let me show you. If you look here on our website, you can see that we've done some repairs on this inverter. So this was a GF8048M8W. So it's the same inverter. You can see the fault that was reported here. It was not switching on, faulty control board. So it means that this inverter, it didn't have a short like this one. So why I'm saying that is because there's a faulty control board. So if there was a short, it will have been written there that there was a short on the battery terminals. So here there was no short on the battery terminals. The problem was on the control board. So if you go down on the website, you will see that the board was changed. It was this one. So that's the board that we changed to repair that inverter. Yeah, so that board is a control board. Is the board that controls all of the functions of the inverter. You can see the CPU, the drivers, the optocouplers, and all the communication cables. They go to that board. So that's why we call it a control board. So that's the board that was replaced on that inverter. You can see that it came from Kimberley. It was with the help of courier guy. So that's when we were busy there. Okay, so we're gonna do the same today. We ended up repairing it. You can see there was an output there. So let's try and sort out this inverter. So this inverter, it's the same model. I've already opened it. Let's take out the cover. Okay, here is our terminals. So there's a short between these 2 points. So this is where you connect your battery positive and negative. So when the inverter it's okay, there must be no short circuit. Look at that. I'm gonna measure with the ohms meter. Check out the multimeter there. You can see that we are reading 0 ohms. So that's a dead short. So that's the dead short. So obviously the input stage is affected. So we also have to check the output to make sure that there's no short on the output stage. Otherwise, if we repair the input stage only and leave the output, the same thing will happen again. So let's take out the card. I'm going to remove this main board, and then we can test and do the measurement and see what's happening here. Okay, here is our board. So we have to check all of these transistors. Let's check there between the gate and the source. You can see I've got 0 ohms. So that transistor is not right. Second one, 0 ohms. So it means that these 4 are gone because this is a pair. This one, 0 ohms. So I shouldn't get a low resistance here. See, 0 ohms, 43 ohms. It's not good. Let's check the other pair. Also not good. The other pair, the last pair. Also not good. So we have to change all of those transistors. So that's what we need to do now. We have to change all of the 16 MOSFET transistors. And let's check the output stage, the IGBTs. Okay, you see there, between the gate and the emitter, we shouldn't get low resistance. You see, this is reading okay. This is okay. Let's check the next one. There's no short. So it means that the short was only on the battery terminals, because this is the inverter IGBTs. So this tells us that the inverter had a problem on the DC, not the AC side. Okay, let's remove all of those transistors and then we can see how it goes. Okay, the easiest way to take out these transistors, since we are taking a whole lot, actually we're taking everything, all the transistors has to come out. So the easiest way is to remove this heat sink. Then the transistors will be alone, because the heat sink, when you do some soldering, it takes away the heat, and then it's not going to be easy for us to remove the transistors. So I'm gonna remove all of these screws and all of those screws there inside, and then we can remove the heat sink. Okay, I've just took out all of the screws. You can see the heatsink is now out. But there's one thing that we need to be careful of. You can see here I've got 8 screws with the plastics. So those screws, they go to this side of heatsink where there's an insulation. So if I put the screw directly, what's going to happen is the MOSFET will be bonded to the heatsink. Then you have just created a short circuit by that. So these screws are there with the plastic to insulate, and also there's an insulator here. So I've got 8 of them that we need to put the plastics. Okay, we are now going to remove all of the transistors. Okay, I've just removed the 16 transistors. These are the 16 MOSFET transistors. So this is the points where they were. So we have to clean all of the holes and make sure that the holes are open so that when we put new transistors, it will be easier for us. Let's clean it. Okay, now it's another day. Sorry, I had to cut the video because it was late for me to continue recording. So I'm gonna continue from where I left. Okay, yeah, all of the holes are now okay. You can see 16 holes are okay. They are now open. Okay, here's the new transistors. So we're gonna take 16 transistors from there and install on the heatsink. Okay, we are now going to install the heatsink, but we have to be very, very careful because the heatsink, it is mounted directly on these two bus bars, and these bus bars, they go right to the transformer. So the first point, it goes to this bus bar, the first point of the transformer. Then the second point is just like a coil. So the first point of the coil goes in here, then the second one goes in here. So the reason why I'm saying we have to be careful is that if I connect the heatsink directly on top of this bus bar and put the screws, I'm gonna create a dead short between the windings. So these are the windings basically. So I have to make sure, that's very, very important. We have to make sure that we don't lose the insulator. Remember, when we take out the heatsink, we took out this insulator. So this insulator is there to make sure that the heatsink doesn't get in contact with the windings. And then our other point, there's another insulator here. So the heatsink will be running just on top there. The insulator, I mean, just like that. You can see. So the screws must align there. See there. Okay. So let's put it. If we don't put this, you don't have a working inverter. You will never have a working inverter because the windings are there to change the voltage, to step up the voltage. Okay, we've installed the heatsink. So just to make sure, I'm going to check the continuity between the heatsink and the coils. These are the two bus bars. So let's check if there's a continuity. If there's a continuity, then it's a fade. So the heat sink, it's mounted to these screws. So let's check between here. So you see we've got an overload. So there's no continuity. You can see my meter is working. Because if I check between the screws here and here, I will get a continuity because it's a one heat sink. But we shouldn't get any continuity here. If that's the case, then remove the heatsink and reinstall it. Okay, now we have to install the transistors. So you remember these ones, we have to have the screws with the plastic. So that's the screws that we have to use. Okay, we've just completed the installation of all of the MOSFETs, all 16 MOSFETs. So now before we can test, you can see we still have to do the soldering there. But we have to check, especially this pair, you see all of these ones, we have to check if there's no short between the heatsink and the source. So here, if I measure there and there, see I'm getting 10 kilo ohm, 9 kilo ohm. That's perfect. So there's no short circuit between the source and the heatsink. Because if there's a short, then the inverter will have a short circuit on the DC terminal. So let's check here again. Source and the heatsink. Nothing. So these ones, obviously there will be a short because they are already connected directly to the heatsink. So we are good. So let's test the battery inputs. Remember, we're getting a short here. Okay, you can see now we're reading high resistance and it's picking up. It's now charging the capacitor. That's why it's picking up the resistance. It looks okay. That looks perfect. So now let's do the soldering, check again, and then we can test the inverter. Okay, we are now done with the soldering. You can see all of the transistors are now soldered. Let's clean. We use this contact clean 530. Okay, we have cleaned the board and changed all of the MOSFETs. Let's check the resistance between the positive and negative of the battery terminals. You can see on the resistance there I'm getting 60 ohm and it's picking up. It will go up to kilo ohms. The reason why we are getting the low resistance at first is because the capacitors are discharged. So this multimeter is now charging the capacitors. You can see we are picking up now. So that's good. That's okay. So we no longer have a short circuit. I'm happy with that. I'm sure you are all also happy with it, because you remember we're getting a 0 ohm on the battery terminal. Okay, yeah, I think we can now test this inverter. You can see those are the MOSFET that we changed. Let's test it and see what do we get here. Did we win or not? Let's connect the control board and test it. So there's no more short circuit on the battery terminals. We should get power on the display, but we're gonna see. Okay, here's our display. Okay. Okay. Let's switch it on. Okay, the 0 1. 0 1 is the fence. Okay, so it's showing error 0 1, which is the fence. Let's switch on again. Yeah, we've got 0 1. Let's connect the fence. So some of the inverters you can test without the fan. Some of them they won't work without a fan. So we have to connect the fence. Okay. Okay, I've got the fence connected. Here is the fence. You can see these are the cables for the fence. Let's switch on and see what do we get now. Let's hope it works. It will be okay. There's a relay. Oh 09 09 error 09. Yeah, we've got multiple problems on this inverter. So we've got error 9 now. Let's see. Why are we getting error 9? What is error 9? So error 9 happens when the inverter checks the voltage. There must be a DC bus here, 500 volts. So if we've got error 9, it means that there's no voltage here. So it's strange because we've checked all of the IGBTs, they were looking okay. Because most of the time error 9 is caused by those IGBTs. Okay, let's check and see. Let's check and see. So these are the IGBTs. Let's measure again. And see, I don't have a short there. No short. So all of the IGBTs are looking okay. Okay, let's check between the positive and negative of the capacitor, which is these two poles here. This is the big capacitor. Yeah, that's the problem. We are having a 0 ohms. So why are we having 0 ohms, whereas all of the output IGBTs are okay? It means that maybe the MPPT, because the MPPT also boosts the voltage from the solar panels. So where is the MPPT? Let me show you. This is the MPPT board. This is the charger board. So your solar cables comes in here. This is positive and negative for your solar panels. Then they go to this coil here. I'm gonna turn it so that you will see. Then they go to these IGBTs. Then they will be the voltage will be boosted to the DC bus. You can see it's linked to this. All of these capacitors are linked. So we've got 1, 2 capacitor. Let's turn it. So our solar PV comes in here, positive and minus. There is the coil. It goes in here to the boost coil, 500 volts. And then it's linked. You can see these two copper traces goes to the IGBTs. So let's check these IGBTs. It must be the problem. The output stage is looking okay here. Let's check these IGBTs. Yeah, that's bad. So the problem is also on the IGBTs for the solar panels. So we have to change these two IGBTs. Yeah, that's the big problem now. So I'm gonna remove them. Let's remove this. This is the thermocouple for the IGBTs. Those are the two IGBTs that we need to change. They've got a short circuit. So this tells us that the problem was on the PV side, and then it damaged the IGBTs and those 16 MOSFETs. So this inverter, it has got a built-in MPPT. Some of the inverters, they've got a separate MPPT board, but this one is built in. So now we are basically fixing the MPPT. So this is the MPPT board. So this is the MPPT charge control IGBTs. So let's check them again. Truly, I was hoping that this inverter will be simple to repair, but now it's, yeah, you can see the between the gate and the emitter, I'm getting 12 ohms. Not good. Let's check the diode. Even the diode needs to be replaced. Okay, there is the diodes. There's the new diode and transistors. Okay, we've got three components replaced there. Let's check the resistance. You can see that they are working. You can see I've got the overload there, so I'm not longer getting any short here. So that's good. That's good. Very, very good. So let's install it. Okay, we have replaced the MPPT transistors and the IGBTs. I mean the transistors and the diode. Let's check again if we have a short on the capacitor. That looks good, eh? That looks good. Okay, let's test the inverter again. And remember, we have to connect the fans on this inverter, otherwise we're gonna get error 1. So some of the inverters, like I've mentioned, you can test without the fans. This one you really need a fan. Okay, let's connect the control card. Okay, now we can connect the power. Okay, there is our display. Okay, let's switch on. Okay, to switch on, I'm just putting a bridge piece there. I'm sorry I didn't show you. See, when I put a bridge piece between these 2 points here, these 2 points, the inverter will come on. You hear that? Yes. Okay. Let's switch on again. That's how we switch on when we are testing. There we go. There we go. You can see we now have a 230 out. So the inverter is okay now. We are done with the repairs. Very, very good. The inverter is okay. I've just switched it off. Let's switch on again. That's good. So the MPPT was giving a fault, error 9, and the MOSFET was shorted. There we go. Yeah, we are done with the repairs. Thank you for watching, and I hope to see you on the next one. What we have learned on this video is that the MPPT can cause the error 9, and also the MOSFETs, when you change, better change all of them, because all of them were shorted there. We change all of them. It's quite a job, but we've done it. Thank you for watching. Hope to see you on the next one. Keep well.